Hi, everyone, and welcome to our partner webinar, SoC to Cloud, iWave Security IP Suite enabled with wolfSSL, presented by iWave project leader Krishna Prasad and wolfSSL senior engineer Chris Conlon. My name is Riley DeGarmo, and I'll be moderating today's webinar. All attendees will be in listen-only mode, so if you do have questions, please use the Q&A box at the bottom of your screen. This webinar will be recorded and made available on our YouTube channel at a later date. I invite you to follow iWave Systems and wolfSSL on our socials, and please feel free to email us with any additional questions following the presentation. So now I will turn it over to iWave to begin the webinar.
Thanks, Rai. Hi, everyone. Myself, Krishna, working in iWave system as a project leader. And today we are explaining about iWave security suite, which is integrated with wolfSSL. Our primary aim is to provide end-to-end security and also to protect device from any type of security threat. So let's start with a quick introduction about iWave. iWave is headquartered in Bangalore, India. We are global players with strong footprints in US, Europe, Korea, and Japan. We are established manufacturing ecosystem. We have over 20 years of experience in embedded industry, and we are trusted customer base with various domains like automotive, industrial, and medical. These are the key embedded solutions, and we are categorized into three categories. First one is SOMs, so system on modules. Here we are the NXP Gold partners, and we are offering SOMs in a various form factors. The SOMs comes with the core components such as processor, eMMC, DDR, and it is easy to integrate with any carrier board. And another solution is engineering services. So we take the requirement from the customer and we design and manufacture hardware as per the customer requirement. We also support software, board bring up activities, porting of OSs, application, GUI development, Wi-Fi solutions, FPGA solutions also. We have enabled OPTI, a secured execution environment in IMX6 and provided to our customer. Coming to the ODM solution, we are offering OBD2 dongle with Wi-Fi, LTE, and CAN-FD protocol. This is suitable for any type of vehicles with OBD ports. Other than OBD dongles, we are also having rugged handheld device which can be used in any type of tough environment, and also we have HMI solution with various GUI framework integrated. Coming to IMX8 SOMs, we are offering SOMs for IMX8M, IMX8QM, IMX8 Mini and Nano. And if any customer want complete solution from iWave, we have single board solution also. So coming to the main topic, iWave security suite and how we are integrated the wolfSSL here. So main agenda of security suite to protect device from any types of security threats. And currently we have integrated with our IMX8M EVK with Linux OS running on it. We have provided API layer in a SDK form so that customer end application can make use of our API for enabling or disabling the security features and make use of encryption, hashing, and different functionalities. In an API layer, we have integrated wolfSSL library for making use of encryption, hashing function, and the secure TLS API layers. Coming to the Linux OS, we have the crypto dev Linux to talk with the hardware accelerator, and also the iWave security driver for exposing the NXP SoC level features to the user space. In the kernel configuration layer, we have net filter, that is a software firewall for blocking the unauthorized access from any IP address or protocol or ports. Auditing daemon for logging any type of malicious events. It could be unauthorized login access, insuccess login attempts, etc. Device mapper mainly for the securing the storage. And a sector level protection, encryption protection we are providing and securing the storage. Let's talk about security features in IMX8. Coming to the CAM. CAM is the main hardware accelerator, and it implements various encryption and hashing function, runtime integrity checker, and pseudo random generator. Here mainly we are using the wolfSSL library to in upper layer for accessing these functionalities. Tamper detection, mainly protection from the runtime tampering, and monitoring of various alarm sources. It could be temperature monitoring, also voltage monitoring. AHAB is a high assurance boot offered by the another NXP feature, which prevents unauthorized software execution. So here we are signing all OS binaries with the help of NXP provided CST tool, and also we are fusing the SRK hashes in the boot ROM so that each boot the ROM will authenticate, and then only we can proceed for the boot. Secure debug is another feature where we are enabling the password protector feature for securing the debug interface. In terms of OS level security, we have crypto blob feature for encrypting the sensitive data and storing in an encrypted blob format, so that any types of sensitive data such as password, key, everything will be saved in an encrypted format, and it can be decrypted only and only by CAM. Coming to OS hardening, here we are enabling various security flags in OS level as well as in a Yocto level, and we are making the system from any types of internal or external attack we are protecting. Also, we are avoiding the chances of reverse engineering. The secure file system, here we are protecting the core file system. It could be a eMMC or SD card or any types of storage using the dmcrypt Linux, which internally accesses the CAM. The secure communication with the cloud. So iWave suite is making use of TLS 1.3 secure protocol for accessing the cloud over the secure port. So definitely we are making use of wolfSSL APIs here, which is providing very good performance and security while transmitting data to cloud. Here we are explaining about how iWave security suite can be used in automotive industry. So here we are showcasing our suite features in different layers. Coming from IMX8, we have enabled the secure boot. The cryptography layer enabled with wolfSSL. Tamper detection feature is enabled. Secure JTAG for debugging, securing the debug. File system securing, storage securing, and over-the-air protection update feature also we have provided. Coming to the connector level, the vehicle interfaces level, the all interfaces are secured with the protocols. The network level, it could be Wi-Fi, Ethernet, everywhere security protocols enabled. CAN level, we have enabled the frame filtering for avoiding the unauthorized packets, and anti-theft security is enabled with the help of battery sensors. Communication interfaces, the access control we are using for deciding what application should run, which should not run. Secure file system for encrypting the file system, and only the virtual layer will be visible to the user. Firewall for blocking the unauthorized access from any unauthorized IP address. The wolfSSL TLS for secure communication to the cloud. Also, we are enabling the token or property for the access to the cloud, and this will be saved in a blob format. Here we are explaining what are the various types of threats and how iWave's security suite can handle it. Any unauthorized software execution in IMX8, we are preventing with the help of a secure boot AHAB feature. If any credential misuse feature is there, we have blob as well as the secure TLS communication. And any threat during data communication, again the wolfSSL TLS feature is coming handy here. This is the performance statistics which we have captured with our IMX8 dev kit by enabling hardware accelerator and without hardware accelerator. We have captured this performance for various encryption and hashing function. I'll make one more note that this is not final number. We are still discussing with wolfSSL, and there is still more optimization is going on. Okay, so from here, Chris will take over. Thank you.
Great, thanks, Krishna. This is Chris Conlon. I'm an engineering manager at wolfSSL. And today I'm going to add to Krishna's presentation here by sharing a little bit about wolfSSL. We're going to start with the history of wolfSSL. We started out of MySQL, the database company, in 2004. At that time, MySQL needed a clean room SSL implementation. And so we rewrote our first SSL library, which is called YASL, which stood for yet another SSL, in C++. And between 2004 and 2006, the market demanded, or was really asking us for a C-based library to fit better on embedded systems. So we rewrote YASL from the ground up again, this time in C. That was called CYASL. And then in 2014, we renamed CYASL to wolfSSL, just to be more consistent across product naming and company naming. Today, wolfSSL has over 1,000 commercial customers and 17 resale partners. We estimate we secure over 2 billion active connections at any one time on the internet. And we are experiencing some pretty active growth. In 2011, we were 3 people. Now in 2020, we're up over 34. This slide has an overview of our current products. wolfSSL is our main product. This is our SSL and TLS library. Underneath wolfSSL sits wolfCrypt. This is our cryptography library, which does come in a couple validated and certified variants for FIPS on 4E-2 and DO178. We also have an asynchronous crypto module for use on the server side. In addition to our SSL and crypto, we have an MQTT library, an SSH client and server implementation, a TPM 2.0 library, and a secure bootloader called wolfboot. All those products in the first green boxes are written in C. We do have users that like to use this from other languages. So the second row here is showing a set of language wrappers we have available for Java, C#, Python, and JavaScript. And then the last row is just a set of applications. It includes an SSL termination proxy, a simple certificate enrollment protocol implementation, a secure update solution, a command line utility. We do offer commercial support packages and feature additions to curl. And we have a version of curl that's pared down meant for resource-constrained devices, which is called tinycurl. All these products are dual licensed under an open source GPL v2 or v3 license, as well as a commercial license. If we look a little more at wolfSSL, wolfSSL is written in C. It supports up to the current TLS 1.3 and DTLS 1.2 protocol standards. We've designed it to be very lightweight with a 20 to 100 kilobyte footprint, depending on build options. Runtime memory is 1 to 36 kilobytes per session. And wolfSSL itself is very portable. We support over 30 operating systems now, which you can see on the bottom of this slide. That's everything from your standard Windows, Linux, Mac, through a bunch of RTOSes all the way down to bare metal. A few other features of wolfSSL include an OpenSSL compatibility layer. This makes it easier to port applications that had been using OpenSSL over to wolfSSL. We've ported wolfSSL into a number of different web servers, including Nginx, Lydie, Apache, and Mongoose. We have hardware cryptography support for a number of different platforms. Today we're talking about our CAM integration on the NXP IMX line. wolfSSL is NSA Suite B compatible, and like I mentioned, also has our FIPS 140-2 validation. So wolfCrypt sits underneath wolfSSL. This slide shows you the algorithms we currently support. This is all your standard algorithms, in addition to some more progressive ones like Cha-Cha 20, Poly 1305, and Curve and Ed 25519. So the big question we get asked, why should customers and users choose wolfSSL? We think there's a lot of great reasons, and over the next few slides here, I'm going to call out some of our favorites. So first of all, wolfSSL products are built for portability, modularity, and performance. Portability, like I mentioned, we support over 30 operating systems down to a bare metal environment. We've tried to abstract out all system level dependencies, including things like I/O. So if you need to run TLS over something other than TCP/IP, maybe serial or proprietary transport, that's something that's very easy to do. Modularity, all of our algorithms and features can be easily compiled in or out based on one preprocessor define. And performance, our team is continually working on optimizing performance, both in our software-only code and in our integrations with hardware cryptography. So low memory usage. This has been a goal for us from the beginning. We have a lot of customers on embedded resource-constrained systems where we know that memory is very precious. And so we do our best to optimize for small footprint sizes and low runtime memory usage. And mature and widely used. wolfSSL was founded in 2004, which means that we've been around for over 16 years, securing all kinds of different products worldwide. That means you'll find, a lot of the bugs and kinks have been worked out, and wolfSSL is a very stable product today. Commitment to security and features. wolfSSL is committed to keeping our products secure. Through doing excellent testing, we keep bugs and vulnerabilities to a minimum, meaning that our customers have to update less frequently on their end and have a more insecure product. We have a commitment to maintaining features, so we don't want to break features for backwards compatibility. We also have a commitment to staying progressive in both algorithm and protocol support. We were one of the first ones to implement TLS 1.2 and also one of the first ones to implement TLS 1.3. Well supported. All of our original code authors and engineers are still on our team today. And so that means our customers, get support directly from wolfSSL engineers. Since we have the original authors, we can fix bugs and issues more quickly. And our wolfSSL products are also reviewed by our extensive community of open source users and our customers. Certified and validated versions of wolfcrypt are available. We know that we have customers who require these in certain use cases. FIPS 140-2 and soon to be 140-3 for government and DoD type customers. We have NIST CAVP validations available, and also DO-178C level A for our avionics customers. And then the last advantage I'm going to talk about today with you is our dedication to testing. So wolfSSL really believes we have the best tested SSL and TLS and crypto implementation available on the market today. We put a lot of effort into testing and expanding our test cases. You can see some of the types of testing we do on this slide. So it ranges from API unit testing through Cypher suite and algorithm testing, benchmark testing, static analysis with tools like Coverity, ScanBuild, Facebook Infer, detecting memory errors with Valgrind and fsanitize address, doing interrupt testing, doing real-world build testing, compiler testing on both embedded and desktop sides, peer review, third-party testing, fuzz testing with over 6 different fuzz testers, and we wrap this all up into a continuous integration cycle using Jenkins. So if we take a quick look at our CAM support, wolfSSL has been tested on the IMX 6, 7, and 8 platforms with support for CAM. CAM standing for Cryptographic Accelerator and Assurance Model. There are 4 different ways you can use wolfSSL with CAM. On Linux, you can use CryptoDev Linux or AFLG. These are modules that are loaded into the Linux kernel that allow access to the Linux crypto drivers. You can also use us on Green Hills Integrity or QNX through custom drivers that we've written for those platforms. So if we look at how do you build wolfSSL with CAM support enabled, if you're using CryptoDev Linux, we have an enable option called Enable Dev Crypto. You can also have more control over that by adding modifiers for specific feature sets, for example, CBC, hash, AES, or all. If you're building for AFLG, we have another separate enable option called Enable-AFLG. And then if you're on Integrity or QNX, you'll need to get in contact with us to get our custom driver code and instructions for compilation. So this slide shows you the algorithm support we currently have for the CAM driver. On CryptoDev Linux and AFLG, we support SHA-256 and AES in ECB, CBC, counter, and GCM modes. On Green Hills Integrity, we support AES, a number of hash operations, MD5, SHA-1, SHA-224, and SHA-256, the TRNG, and also blob creation and opening. And on QNX, we support AES CMAC, ECC, keygen, ECDSA, signature generation verification, and ECDH shared secret, in addition to black key blobs. So how do you get started with wolfSSL? Since we do provide an open source version, you can download that right from our website. That would be our stable releases, or you can follow us on GitHub for tracking our development progress on a day-to-day basis. So with this slide, we'll end in a summary, which I'm going to turn it back over to iWave to talk over.
Yeah, thanks, Chris. So coming to the summary, so iWave provides end-to-end security for automotive, industrial, and other applications. So we are making use of wolfSSL with powerful TLS 1.3 for transmitting the data very securely. With wolfSSL libraries, iWave provides customer a safe and very secure environment to perform any types of secure function. It could be encryption, decryption, hashing function, and storage, data transmission, certificate management. wolfSSL and iWave, by joining hands together, brings in providing a complete product solution involving hardware platform, associated software with a robust security. Yeah, thank you.
Thank you so much, Krishna, with iWave, and thank you to Chris as well with wolfSSL. As we conclude today's webinar, we can move into a question and answer. Again, just as a reminder, there's a box at the bottom of your screen where you can type in any questions that you have. We'll be happy to answer them. So to get started with the first question, I believe this is for iWave. Any ideas or plans to add SOMs with connectors on the bottom of the board, like the VeriSite SOM modules?
I'll take over this question. So iWave is known for offering the custom SOM configurations. We had already done a similar custom SOM module support as part of our custom services. Yes, the answer is yes. We can provide the custom SOM with the connectors that this particular customer is asking for. Maybe offline we would like to discuss with you and provide the necessary support.
Excellent, thank you. We can allow a few more minutes for any other questions that folks might have. Please don't hesitate. Here's another question that's come in. Actually, perhaps this is more of a comment, but maybe iWave and wolfSSL can comment on this. The security feature available with OBD modules as well? And does it increase the price? That sounds like more of a question for iWave, I believe. And I believe the question is this security feature available with OBD modules as well? And does it increase the price?
Currently, we are offering OBD module with IMX6 UL. In IMX6 UL, we provide some of the security features, secure boot, and all are not covered, which are coming with IMX8. And that is already inclusive. Currently, what security suite we integrated, that is with IMX8.
Excellent, thank you. And we can allow just another moment for any other questions. Oh, here's a good one. Is there a royalty-based fee?
Yes, we would like to discuss this offline, this particular customer.
Absolutely. Another question that we have is, are the security features to be used with IMX systems instead of NXP HAB utilities, or as well as HAB?
Sorry, question was not clear, but our understanding is IMX. We are using the IMX8 AHAB feature with the NXP provided CST tool and HAB utilities. That's on IMX8 only currently we are doing, and even OBD supports HAB feature. Whether our answer is relevant to the question, or if it is not, maybe you can reframe the question.
Okay, great. Yes, thank you. Hopefully that answered that question, and we invite the attendee to follow up if not. And the same goes for the question on royalties. We invite the attendee to follow up to have that question answered as well. Thank you. And we can hang on for just a couple more minutes for any other questions that attendees have. But again, as a reminder, please follow iWave and wolfSSL on our socials. We will make this presentation available at a later date. We thank you all so much for your attention. If there are questions that you have that come up or that were not answered today, please follow up with us directly. And we very much look forward to learning about your projects and how we can best support them. I think with that, we can conclude the session for today. So thanks again to iWave. Thank you, Chris, with wolfSSL. And we look forward to speaking with you all soon.